Okay, we can also work to solve equations with our fractional exponents. So I've got x to the 1/5 power. Now, knowing how to solve this here is probably going to help us to think of these as roots to start with. So x to the 1/5 power, okay, if I'm remembering jam, okay, that's going to be the jth root of a to the n power. Remember that Mr. Schieber dunked over Jaron, okay. The 5 is down low, which means the 5 is going to be out here. So what this really is this is the 5th root of x equals 5. Okay, so how could I get rid of the 5th root? Well, if we don't know about the 5th root, say this was a square root. I need to write that 2 there, sorry. Say this was a square root of x equals 5. Well, if you got to get rid of square root, you're going to take it to the 2nd power, right? Same on both sides. So same rule as if it's a 5th root, I'm going to need to take both of these to the 5th power. Okay? Now, if I think about this, if I'm taking this to the 5th power, this is now a power to a power rule. So I'm going to have to multiply those two together there. Okay? What's 1/5 times 5? Well, that's just an x to the 1st power. Okay? So I'm going to take it to the 5th power here as well. 5 to the 5th power. Oh, I'm not sure what that is. 625 times 5, 25. 10. 31. 3,125. Okay? So the answer to this here, okay, is going to be x equals 3,125. Now, when I'm going through this is the important step right here. This is the important part. How did I come up with that 5? Okay, well, I had 1/5 as my exponent, and I took that times 5, which should be 5 over 1. So this exponent here, that we take it to that power, okay, the exponent that we take it to the power is going to have to be the reciprocal. Every time I solve this, I'm going to take it to the reciprocal power to figure out. So this number out here, this 5, is always going to be the reciprocal. Okay? So, next slide, we're going to have one that's a little bit more challenging, I guess. Okay, I've got x to the 4/3 power equals 81. So something to the 4/3 power. Okay, I've got to take it to the reciprocal because the reciprocal will cancel these two out. Okay, that means I've got to take my 81 to the 3/4 power. Okay, so 3/4 times 4/3 is going to give me 1. That's just an x now. I've got 81 to the 3/4 power. We're going to want to use our jam rule again. Okay, remember that Mr. Schieber dunked over Jaron. Okay, so this is a 4th root of 81 cubed. Okay, and I'm actually going to want to do my 4th root of 81 first. Okay, that's going to give me a 3 cubed, and 3 cubed is 27. Okay, and then last two things, we can use our jam rule to help us to simplify these. Okay, so in the past, what I told us to do is I told us to write all these out. So 32 would be 2, 2, 2, 2, 2. A to the 10th would be A. Oh my gosh, that's going to take forever. And I would be looking for groups of 5, right? So we can use our exponent rules to help us with this. Now, I'm going to tell you guys right now when you do these, numbers are easier with roots, so leaving them as roots, okay? And variables are easier with our fraction exponents. Okay, so the first thing that I do is I would simplify and I would separate these two. I've got a 5th root of 32 and I've got a 5th root of a to the 10th, b to the 15th. Okay, now roots are easier with numbers because you can plug that in your calculator if you need to. That's going to give me a 2. Okay, this second part over here though becomes a to the 10th, b to the 15th to the 1/5 power. Okay. And then my 1/5 distributes. Okay. Or my other option is that I can even separate this further. I can make this a 5th root of a to the 10th and a 5th root of b to the 15th. And now I'm doing my jam rule on these two separately. That's a to the 10 over 5. That's b to the 15 over 5. Okay, so essentially all I'm doing is I'm just dividing. Okay, 10 divided by 5, 15 divided by 5. That gives me 2a squared. 10 divided by 5 would be 2. And then b cubed. 15 divided by 5 would be 3. Okay, so the fractions kind of give us an easier way to think about it, and it's especially easier with the variables. Okay, the roots I usually tend to like better because I can just plug those in my calculator. Last example. We're going to deal with some cubed roots. Okay, I've got a cubed root of x to the 6th, y to the 12th, divided by 54. Okay, it doesn't matter that these are divided. This cubed root goes to everything. So again, I can separate this. Cubed root of x to the 6th, cubed root of y to the 12th, over cubed root of 54. Okay, so this is really just a 6 over 3. X to the 6 divided by 3. That's a y to the 12 divided by 3. Okay, I can plug the cubed root of 54 into my calculator, and that's not going to tell me anything. So cubed root of 54, if I'm breaking this down, would be 9 and 6, 3 and 3, 3 and 2. Okay, so group of 3s, that's going to move out in front. 3 cubed root of 2. Okay, and then up top, well, 6 divided by 3, 6 divided by 3 gives me 2. 12 divided by 3, 12 divided by 3 gives me 4. And that's my answer there. Okay, so those fractional exponents, I think, make it a lot easier to be able to divide. Okay, lesson practice problems are up here next. Okay, I want you guys to pause the video, try these out, and then I'll give you guys your answer. So go ahead and pause the video now. Okay, we need to remember our jam rule. Okay, that's a 1. It may help you to write out the jam at the top of your paper until you remember it. Mr. Schieber dunked over Jaron. Okay, so that's a 1 up there with the x. That's x to the 1 over 7. Okay, y over here, 3/5. That's j, that's m. Okay, you just got to compare it to the picture up above. Okay, next slide. Okay, again, if you haven't stopped it, make sure that you stop this. Okay, and you're trying these on your own. Okay, again, no number written out here. That's a 2. Okay, makes that a 1, x to the first power. So this is x to the 1/2. Again, no number here. That's a 2. This is y to the 3/2. Again, make sure you've paused this video if you haven't already. They want us to simplify this. Okay, 49 to the 3/2. Okay, square root of 49 cubed. Okay, well really this is going to be easier to think of it as square root of 49 cubed. Okay, so that's just a 7 cubed, and 7 cubed is going to give me 49 times 7. 9 and 7 is 63. 40 and 7 is 280. So 3, 6, 8 is 7. No, wow. Sorry. 6 and 8 is 14. So 343. Yep. So I've got 343 for my answer here. In this spot, I can multiply those two. So that's really 625 to the 4/16, which is really 625 to the 1/4. Use our jam rule. That's a 4th root of 625, which is 5. Okay. And then last one here. Remember, this is where we want to use our reciprocals. So reciprocal of 1/9 is going to be 9. So that gives me x equals 3 to the 9th power. And I'm going to use a calculator because I don't feel like doing that. And 3 to the 9th power equals 19,683. Okay. This one here, again, use your reciprocal, be 2/5. That's going to give me x equals 4 to the 2/5 power. So when I try and simplify that, that's the 5th root of 4 squared. I don't know a 5th root of 4. So the only other thing that I could really do is I can make this a 5th root of 16. But then that's going to be its simplest form. So I'm just going to leave it like that there. Okay. So that's it. Homework is on the next slide. Got a book assignment, 3 through 30, multiples of 3. So 3, 6, 9, 12. Don't do number 15.